Welcome. This tutorial is based on the Grade 8 Technology Workbook. We are going to cover the areas of writing, measuring, dimensions and scale that you will find in the workbook. This is page 27 of the workbook. It is very important to remember that all headings, notes and annotations in technical drawings must be written in neat capital letters. We mostly make use of an HB pencil for writing. Some teachers might prefer that you use a 2B pencil for writing purposes. All headings and information in title blocks, that means your name, your surname, the date and the title of the drawing, is drawn in 5mm spaces. Subheadings, labels and annotations are written in 3mm spaces. When you write, you need to make sure that your letters and numbers are written uprightly. Look at the examples given below and see exactly how the lines are drawn and the curves are drawn. Once you have practiced this over and over, you'll get very good at this, and your speed of writing will increase. On the right-hand side of the page, we will practice writing your name and surname, also your name of the school, and the date and line. And there's a specific format that we use in technical drawings. This is page 28 of the workbook. Here we cover measuring. It is very important to measure accurately in technical drawings. Ensure that you are using a proper and calibrated ruler. Always make sure that your pencil has been sharpened. You may use a graphite pencil or you can use clutch pencils. A 0.5 and 0.7 clutch pencil will do. When measuring with your compass or a divider, make sure that the metal tip is placed accurately on the correct measurement of your ruler. Measurements are only done in millimeters in technical drawings. That is if you are using a metric system. Below you will find images of the rulers in your workbook, and your teacher will write distances on the board that he wants you to indicate in your workbook on the ruler. And then you write that distance that he has given or she has given onto your workbook. At the bottom half of this page in your workbook, you will find the 3 examples of angles. Make use of your protractor and measure each one of these angles. Write the answers in the spaces provided. It might happen that the angles are too small and you cannot reach the measurement on your protractor. Then make use of your ruler and extend the lines of your angles and measure it with your protractor. This is page 30 of your workbook. On this page, I show you how to do different methods of labeling. Please remember this is not a fixed method and you may adapt it to your needs. At example 1, I am labeling with letters and I'm doing it in a clockwise direction. I start with A and go to the next corner B, C, D, E, F all the way to H and back to A. At number 2, I am using numbers from each corner to corner 1, 2, 3 all the way to 6 and back to 1. At example 3, I have baseline AB and then a perpendicular line CD that interacts with line AB, and D is the point of interaction. At number 4, I have an angle and I started with 1 at the top, 2 in the corner and 3 at the bottom. You could do this the other way around. At number 5, I have a 3D shape. This is an oblique image of a cube. I have numbered the front corners as A, B, C and D, and then in the depth I have labeled E, F and G as you can see here. You can place E, F and G anywhere you like at the back, or you can start with A where B is, or whatever suits the purpose of your drawing. At number 6 we have an isometric block, and here I've just used numbers, and I show you how from corner to corner I have tried to use a sequence for the numbers. Yours does not have to look the same. This is page 32 of your workbook. Here I am showing you how to do dimensions. Dimensions are a bit more technical, and therefore there's a very specific way that we need to indicate dimensions on a drawing. At the top left you will find the 2D drawing. On this drawing we will see that there are guidelines that are drawn just a little bit away, normally a millimeter or 2 millimeters away from the model, and at an angle of 90 degrees because that's a 2D drawing. Then notice how the arrowheads just touches each of the guidelines coming from your model, and we write the measurement on top of the line. When we indicate the diameter of a circle, we show the symbol of the diameter and write the distance of the diameter. Also note that the arrows go through the center of the circle, in other words where the vertical and horizontal center lines of the circle meet. And we extend that line a little bit so that we draw the diameter of 10 on a little flat line. At the bottom where we have multiple dimensions, we see 15, 40 and 15 millimeters, and in total it's over a span of 70 millimeters in distance. Please note how one has to indicate a dimension like this. On the far right you see an isometric model or isometric block, and here we indicate the guidelines also starting a distance away from the block itself, and we draw the guidelines at an angle of 30 because the isometric drawing is drawn at 30 degrees. Notice how we indicate the arrowheads and that it touches the guidelines. We are writing the measurements on top of the line. Also note that you do not have to draw this unit of millimeters in examples like these, because in a metric system all drawings are drawn in millimeters, and therefore we don't need to indicate the unit millimeters. At the bottom left of your page you see what we do when a distance is less than 5 millimeters, and we do not squash in or cramp in the dimension into the drawing, and therefore this is the method that you will use to show any distance less than 5 millimeters. You would draw the guidelines and draw the arrowheads on the outside of those guidelines, and you write the measurement on the line. At the far right is just a close-up view of how to indicate a diameter of 10 for a circle like this, or you could have written just an R for radius of 5. This is page 33 of your workbook. On this page you will find two models given to you in 3D preview. These two 3D models will show you what the model would look like in real life. The front view of each model has clearly been indicated. At the bottom of each model you will find the 2D schematic view of that front view of each model. You need to add at least 5 dimensions to each of the schematic views at the bottom. Please make sure that you apply the correct methods as you have learned from your previous notes in the workbook. You need to add the dimension lines, the guidelines and arrowheads that is indicating the distances on each of the schematic views. Also make sure that you add the distance above the dimension line at each view. This is the answer to page 33 of your workbook. On this page we have added a backdrop, a grid, to show you what these 2D schematic drawings will look like if they were drawn on a grid paper. For the remainder of this tutorial you can ignore the grid. We have added the guidelines, the dimension lines, and the writing which indicates the distance of each of the sides of the 2D schematic models. Please notice that we have written the dimension or the distance on top of the line. We have also added center lines on the right hand side to show where the central point of the arc will be. We also show you how the dimension line will be indicated when the circle has a radius of 30 millimeters. Please also note that the arrowhead will be drawn on the inside of that arc from the central point, and the dimension line will be extended and then have a horizontal flat line on which the radius of 30 will be written. Here is the answer without the orthographic grid in the backdrop. This is pretty much what your answer will look like on your workbook's page. On page 35 of your workbook, we continue to discuss different types of scales. In your workbook on the previous pages, you will find other scales that are not mentioned in this tutorial. But we use this page to explain some very important features. At the top left, we have a scale of 1 to 1. If we relate it to a scale of 2 to 1, we need to divide the scale of 1 to 1 by 2. Therefore, if 100 millimeters is found on the 1 to 1 scale, that exact same distance would be 50 millimeters on a scale of 2 to 1. If you are working with a scale of 2 to 1 and related to a scale of 1 to 1, you need to multiply the scale of 2 to 1 by 2. Therefore, 50 millimeters on a scale of 2 to 1 will be equal to 100 millimeters on a scale of 1 to 1. If you are looking at a scale of 2 to 1 and related to a scale of 1 to 2, you will find that 25 millimeters on the scale of 2 to 1 will equal 100 millimeters on a scale of 1 to 2. On page 35, you will find exercises that needs to be completed. Let's use an example. If you have a scale of 1 to 50 that equals 5,000 millimeters, or in other words 5 meters, you need to divide the 5,000 millimeters with 50 because it's a scale of 1 to 50. That will give you an answer of 100 millimeters on a scale of 1 to 1. Now continue to complete the rest of the exercises. Congratulations, you have successfully completed the tutorial.